Alright, so we're starting off our discussion about surface area and volume, and we're going to kind of have to go through some definitions. And so we're going to start off with what is a prism. So a prism is defined as a three-dimensional shape with two congruent parallel faces called bases. Okay, and the other faces are called lateral faces. Okay, so just to expand on this just a little bit, okay, and it talks about this in number 2. In order for it to be a prism, all of the faces should be polygons, okay, and we can get even more specific and say the lateral faces are going to be rectangles. So always in Prism you're going to have two polygons. They can be any polygons you want: triangles, rectangles, hexagons, dodecagons. You can go crazy, okay, but the outside around the that are not bases, we're going to call those always rectangles, okay? And so when we name we name a prism, we're always going to use the name of the base. So if you take a look at these examples down here, we have two prisms, okay? One of them is called a pentagonal prism because you can see that the bases are both pentagons, okay? So here's where we have to be careful. Excuse me. Here's where we have to be careful. I could very easily take this shape. We don't want to call the bases the top and the bottom of the prism because it's very easy for me to take this picture and turn it on its side, okay, like this, and now the pentagon is not the top and the bottom, it's actually the left and the right, but the pentagons are still the bases because they are the shapes that are never going to touch each other. They are exactly the same size, okay, and they are the exact same type of shape. So we have two pentagons. They are the exact same size, okay, they're identical to each other, and they're parallel, which means they're oriented the same. They're never going to eventually cross. If we were to make them bigger or smaller, it doesn't matter. They're still never going to cross each other. So it's an important note to say that the bases are not the top and the bottom. Okay, they are the two shapes that are identical, that are parallel, that are never going to cross each other. Okay, and then if you notice again in these pictures, when we go on the outside, I actually have 5 rectangles around the outside of this one. In this case, I have 3 rectangles going around the outside, so your lateral faces are kind of going around the outside of the shape, okay, going in a circle around the outside, and they're always going to be rectangles, right? So a couple more definitions. When we're talking about prisms, if we're talking about the height of the prism, we're measuring it as the distance between the two bases. So it's not always how tall is the shape. Okay, it's going to be measuring the distance between the two bases. So again, if it's laying on its side, it's going to be a left to right measurement, not an up and down measurement. So height is not always bottom to top. Okay, like when we think about measuring people, we're always measuring from their toes to the top of their head. But if you're laying down flat on the ground, we wouldn't be measuring from the bottom to the top. We'd be measuring left to right. So the same is true of prisms as well. It's always going to be the distance between the two bases. Lateral area is just the measure of the lateral faces, which is the sum of all of those rectangles. If we measured their areas, the surface area is going to include not only those rectangles, but also the two bases, the top and the bottom. Okay, so here's some formulas. Okay, if we want to measure the lateral area of a prism, you're going to say the perimeter of the shape, the perimeter of the base, okay, times the height of the prism. So again, we'll get into the details about that. And then if you want to measure the surface area, just like the definition says, take the lateral area. Capital B in all of these formulas is going to stand for the area of the base. So we're saying do 2 times the area of the base, which again makes sense because we're going to add in the base at the bottom. Well, let me say that correctly. We're going to add in the two bases wherever they are, whether the top and the bottom or the left and the right. Okay, so let's get right into an example. A lot of this will make a lot more sense when we see an example. So if I say what is the lateral and surface area of this triangular prism, okay, what we're going to do is we're going to say, okay, the lateral area, the definition said the perimeter of the base times the height of the prism. So let's make sure we can identify those parts. So again, we said in prisms, you're going to have two identical shapes that are parallel and congruent. So if you notice the triangle here, right, triangle here, those are our bases. So they want to know the perimeter of that. So let's just do some highlighting so we can identify what we're talking about. So if you notice, I have the 3 sides are the 3 and the 4, but the problem is in this case that the third side of this triangle we don't know. So if we're going to find the perimeter of it, we need to know what that is. Fortunately for us, they gave us a very simple right triangle. If we didn't know that this was a 3, 4, 5 special right triangle, we could just use the Pythagorean theorem and find it out ourselves. But they gave us a nice easy one to work with. So we're going to say in this case that this third side, the hypotenuse of the right triangle, has to be 5 So we can add up the sides now and say 3 plus 4 is 7, 7 plus 5 is 12, the perimeter of the base is 12, right? So if any of those sides are missing, you're going to have to use what you know about right triangles or area or perimeter or any of those things to go and find those missing parts. Okay, the height of the prism, okay, the h that we need to fill in now, is defined as the distance between the two bases. So if you notice, if I were to say, let's connect together, okay, two of these bases, okay, in this case going from top to bottom, I'd be saying, okay, let's start down here, let's find out how far it is to the other base. It looks like I'm going to measure straight up to the top. Up, I've hit another base, I'm done. So that 6 on the side is the measure of the height of the prism, which I could have done any of these other ones. They're also the same. But they told us on the side here that this is the 6. Okay, so the lateral area, it looks like, is 12 times 6, which is 72. We're measuring an area. Area is in square centimeters. Okay, so we'll say lateral area is 72 centimeters squared. So just to drive home the point, lateral area measures, if we were to measure individually all of the rectangles, what is the area of each of the rectangles? We would say that if we were add them all up, we would get 72. So there's one in the front here, there's one in this like the back corner, and one over here to the left, which is also hidden in the back. If we were to find the area of each of those, add them up individually, we would get 72. Okay, so if they now ask us to find the surface area, we're going to say the surface area is equal to the lateral area plus 2 times the area of the base. Okay, well, the lateral area we just found out was 72. 2 is just 2. Well, the area of the base here is going to be, if I pull my triangle out of the picture, okay, it looks like we had a 3, 4, 5. Okay, so we would say that, let's go to our triangle formula. Okay, all triangles can be found by doing 1/2 the base times the height, which for us would be 1/2 of 4 times 3. Okay, well, that looks like 6, right? Half of 12 is 6. So the area of one base is 6. So the area of two bases is 12, and if I do 12 and 72, I get 84 centimeters squared. So we'd say the surface area is the lateral area, those three rectangles, plus 2 triangles, one on the top, one on the bottom, both that are identical, and that have an area of 6. When I add up all those parts, okay, we've now found the surface area of the triangular prism. Okay, so let's do one more triangular prism, and this will be kind of our summary for that. Okay. So in this case, we're going to go through this one a lot quicker. We're going to say, okay, lateral area is the perimeter times the height. Okay, well, the perimeter, in this case, has a 9 down here, and if I'm looking at this base at the top, which again, let's pull out our highlighter tool so we can see what we're working with here. Okay, it looks like a 10 is one of the sides of the prism of the base. A 7 is the other. Okay, oh, let me fix that. Okay. So we have the 7, and then the third side again is blank. So we have to figure out how can we figure out what this third side is worth. Okay, and so what we're going to do is look at one of these faces. This right here, okay, is a face, and if you notice, it's a rectangle, and we know a lot of things about rectangles, right? Rectangles, the top and the bottom are the same. So if this bottom of the rectangle is worth 9, then the top is also worth 9, right? So I can say more clearly now that this is definitely a base that has a 10 plus 7 plus 9 perimeter, which is 26, okay? And then the height of the prism is still the distance between the two bases. That's this 8 on the side. If you notice, it's connecting the bottom triangle to the top triangle, so we'd say it's got a height of 8, okay? And so I can go to my calculator, let it do its thing. 26 times 8, okay, times 8 is 208. So I'll say 208, again, lateral area measuring is in inches squared. So we'll say lateral area is 208. Okay, so now if I want to find the surface area is the lateral area plus 2 times the base. Okay, and so for us that's going to be, we have to find the area of the triangles again. So I'm going to focus on this bottom triangle because the bottom triangle looks like it has a height drawn in for us, right? So this line right here is the height of the triangle, and this is the base of that triangle, which again, I don't know. But if I look again, let's focus on the back, right? This little rectangle right here, okay, it looks like this has a top of 7, which means the bottom of that one is also going to be 7. So I can move this 7 down and find out that I can say that the area of my triangle is 1/2 7 times 8.7, okay? So I'm right now calculating this capital B, so I'm going to say 0.5 times 7 times 8.7 means that one of the bases has an area of 30.45. So we're going to say 2 times 30.45, is equal to, and then the lateral area is the 208. So if I add all this up, this will be the surface area of my triangle. Okay, so we're going to say 30.45 doubled looks like 60.9 plus 208 is 268.9. So that would be my surface area. So again, this is really just going back to our last chapter where we talked about the area of shapes. In all of these, you're going to have to find the area of a shape, and then you're going to have to add in the lateral area, which is just perimeter times height. Okay, so let's wrap up with cylinders. Okay, so the nice thing about cylinders, if we go right to a problem, is that it's the exact same thing as how we did prisms, with the exception that when we find perimeter, right, so here's our formulas. I skipped over it. Okay, if we say like the lateral area generally for prisms is perimeter times height, okay, we're going to focus on just the cylinder ones, and we know that the perimeter in a cylinder, or in a circle, we don't call perimeter, we call it circumference, right? So instead of me writing P for perimeter, I'm going to write the circumference formula, which is 2 pi r, which is the same as pi d, right? So 2 pi r, and then if I'm asked to find the lateral, or the area of the base, instead of me just using capital B, we know it's a circle, and we can replace that capital B with pi r squared. So if you want to write down formulas, you can pause this and use these formulas, and just noting that we're really just doing the same thing as we did with prisms, except we're replacing perimeter and area with what they are specifically for circles, which is 2 pi r for circumference and pi r squared for area, and getting this new formula. But essentially, we're really doing the same thing. So we're just going to do one of these examples, okay, finding the surface area. Okay, so the formula said if we wanted to find the surface area, let's do pi r h. Okay, sorry, let me go back to my formula and confirm. Okay, it is 2 pi r h. I knew I was missing something. So 2 pi r h, and I wrote squared. So let's start over and try this again. Okay, 2 pi r h plus pi r squared, which is 2 pi r squared, because there's a circle on the top and a circle on the bottom. Okay, so if I plug in, my radius is 3, so it's 2 pi times 3 times 5 for the height, plus, let me get rid of the second one so I have some space. Okay, delete this. Okay, and then we can say that the area for this is 2 pi times 9 squared. Let's leave our answer in terms of pi because it's something that works out. 2 times 3 times 5 is 30 pi, okay, and 2 times 81 is 162 pi. So if I add these together, it looks like I get 192 pi. I'm measuring an area, so I'm going to say centimeters squared. So you can see this is really no different. We're just finding the area and the circumference for circles instead of the area and the perimeter for polygons. But cylinders take on pretty much all of the same properties that prisms do. So not a whole lot new. We just have to apply what we know about circles to cylinders.